With this video, we're going to take a look at what an inequality is and how we can graph single variable versions of inequalities. And if you're already comfortable with what an inequality is, you can go ahead and skip forward a little bit until we get to the examples. But for now, let's figure out exactly what an inequality is and get an idea of what it means. So up until this point, you've probably done things like maybe x plus 3 equals 5. You've done equations. You've been solving these equations right here for this variable, whatever it may be. In this case, we have a positive 3, and we're going to do what? We're going to subtract 3. The main idea with these equations is we do the opposite operation and bring it to the other side. So we would get x equals x, x equals 2, because we subtracted 3 from both sides. And you get something, you get an equality statement. You get something equals something, right? And it always equals that for this particular case up here. X is not, in this case, x could not be a 5 right here because 5 plus 3 is not equal to 5. It's not opposite day, right? So for our purposes, you've been solving ones where x is some discrete value, okay? Now, this is where we take a little bit of a different approach when we go to inequalities. The difference with inequalities is x, or whatever variable we're talking about, can be a range of values. There's not just one particular solution. So what you've probably already seen are inequalities can either be a greater than, or excuse me, a less than, a greater than, or greater than or equal to, or excuse me, less than or equal to. And again, it depends on where we place these, or a greater than or equal to. Okay, so we'll go into what these means. But with this, let's just say I gave you about 3 is greater than 5. Is that true? No, it's not. 3 is not greater than 5, right? So we flip it around. 3 is less than 5. And the way that I learned it, and the way that I still teach it, is this inequality symbol right here. What it does is it's kind of like, and this was from like, I don't know, elementary school, but it stuck with me. So let's see if it works. The inequality symbol, it opens up. It's kind of like alligator teeth. It opens up towards the larger of the two expressions, whether this is like a large, like x plus 3 squared, blah, 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 stuff like that. It doesn't matter. It opens up towards whichever side is the largest. And that's what we say. So 5 is greater than 3. We could also say 3 is less than 5. Okay. So that's an important distinction to make. There's two ways we can read this, depending on what side we're coming from. Okay. The only other difference is where there's if you saw I had a less than or equal to symbol. This equal to symbol means it could be literally equal to. It doesn't have to be just less than or greater than. It could be less than or equal to or greater than or equal to. And what I mean by that is if we put, again, if we threw a 3 is less than or equal to 5, that's still not true, even if we put an equal sign. But what if we put 4? If we put 4 is less than or equal to 4, that's a weird 4. Let's try that again. 4 is equal to 4. 4 is less than or equal to 4, excuse me. 4 is less than or equal to 4. That works, right? It's not less than, so that couldn't be true, but it's equal to. So remember, that's what they mean by less than or equal to. So there's two possibilities. It could be less than or equal to. And I keep repeating that because it's important. The phrases that we use, there's actually some terminology that has meaning behind it. So with that, let's go ahead and let's graph some of these. Let's figure out how we graph those. When it's a less than or a greater than, it's going to be represented by an open circle. If it has a greater than or equal to, or excuse me, an equal to symbol underneath it, it's going to be a closed circle when we graph it. Okay, so each of these, we're going to put a 0 as the starting point, wherever we're at. And let's say we had, for this very first one, we'll call it x is less than 2. Okay, so what you do is you find 2. So we started at 0, 1, 2. Here's 2 on the graph, and we know that x is less than 2. So think in your head, well, what numbers are less than 2? 1, 0, right? So you're tempted to plot like, okay, 1, 0, you want to plot these points, but you don't plot them all because it's infinity. You could, negative a million, that'd be less than 2, right? And we're not going to be able to plot that because we don't have that many points. It would take way too long. So what you do is you figure out this point right here, this 2, plot that. And this is going to, again, this is not inclusive. This, think of this equal sign. Another way that you can describe it is inclusive. It includes whatever number is over here. So, but in this case, because I just gave it to you, this will be something that you'll see on a problem. It'll just give you inequalities and say, graph it. Graph this, graph that. It doesn't matter the reasoning behind it. When you're just learning these, you just want to learn how to graph it. So x is less than 2. We have an open circle because we're not including it. and then we're just going to the left because it's less than. So let me actually put that up here. Open circle, and we're going to the left because it includes all of these values, whether it's 1 is less than 2, right? So that's correct. 0 is less than 2. -5 is less than 2, right? Or whatever this number is. -5, -10. So we include this whole solution set. That's why we have this arrow here, because it goes towards infinity. So that -1,000,000 that I was talking about, that's included, even though we didn't graph it, but we did here because it includes this little arrow sign, okay? And it makes sense because if you put a 3 here, right? 3 is not 3 is not less than 2, so we're not going to include 3. That's why any value to the right is not included, okay? And that's the main idea behind what an inequality is. There can be a bunch of extra stuff that we add onto it, like what we'll do in the next video when we have a multi-step or a one-step inequality that'll look just like your equations that you solved. It'll just have an inequality symbol right here. So like x plus 2, the same thing. We would subtract a 2 from both sides, and we would get x is greater than 0, and then we graph that. But for our purposes, we're just focused on how to graph these. So that was less than 2. X is less than 2. Now what about if I gave you x is greater than or equal to -1? So we recognize the number. We know that x is greater than, right? Greater than -1. So you can pick any number. You can think of 0. 0 is less than -1. 1, 2, 3, 4, all those are greater than -1, but it could be equal to -1. So we include, remember that inclusive sign, it's going to be a closed circle. So we start on the -1, close it. And again, let me go back and put it above so you can see it. Include that -1. And where are we going? Which way are we going to point this? If x is greater than or equal to -1, we're going to go to the right. Think of, left as less than, right is greater than, when we're talking about this variable, okay? And you can double check, again, if 1 is greater than -1, then it makes sense that all of these numbers, it's not going to change. Our number set doesn't change randomly or like that. It would defy all laws of, arithmetic that we have. Our number sets would be thrown in the air and it would go crazy. The world would go crazy. But so we assume that this is correct for infinity, past this -1. Excuse me. So with this negative, if we tried -2, and again, it's very tempting if you're not comfortable with negative numbers. If you have like -2 is greater than or equal to -1, you see that 2 greater than 1 symbol. You think, oh, well, 2 is greater than 1. But remember, -2 is not greater than -1. -2 is less than, because it's a larger negative number. So if you plot it, -2 is here, -1 is here. So it's further to the left, therefore smaller. But it is very tempting. You see that, maybe like a -10. These will trick you up, like -10 and -5. They'll say, what's the bigger number? And a lot of times it's like, well, -10, right? Because you're so used to thinking 10 greater than 5. It's been ingrained in your mind. But with negative numbers, it's different. It's a larger negative means it's less, okay? So think of it as like the more negative, the more less it is. the more negative, the less the number is. Okay. So I went off on a tangent there. I apologize. The main idea was to get this right here, where we have it. Let me get rid of that. This right here, that shouldn't be there. There we go. The main idea is when x is greater than or equal to -1, we include the -1 in our solution, because if we plug it in, -1, we want to see, does that make sense? Is -1 greater than or equal to? Remember that or equal to -1, and it's true. It's not greater than -1. Something can't be greater than itself, but it's equal to itself. That little symbol down there, it is equal to itself, and that's why we include it. Okay, so let's try a couple more. What about x is less than? Actually, x is greater than 3. X is greater than 3. So what's our number? Obviously it's 3. So we're going to start over here. We know we're going to start at the 3. Now what are we going to do? Is it going to be open circle or closed circle? Are we not including it, or are we including it? And because there's no equal sign underneath it, the little line symbol, we're not going to include that. That's going to be an open circle. So open circle. Now which way do we point? X is greater than 3, so we're going to the right. All of our solution points that satisfy this inequality are going to be to the right of 3, of positive 3. If we pick this 4 right here, 4 is greater. If we plug it back in, 4 is greater than 3. That's right. If we pick a 5, we could plug it in. 5 is greater than 3. That's also correct. So any other number that goes, if we go infinitely to the right, as far as we can go, that would work as well. And again, that's what I love about these, is you can go in and plug any number from this solution set, and double check and see if it makes sense. If you accidentally went like this, let me put it down here. If you went to the left and you picked 0, is 0 greater than 3? No, that's not right. So that's what's really really nice about these is you can know if you got it right or not. Again, maybe this part, the open or closed circle, that's just, you have to remember that. And think of the closed circle as we're including the whatever solution number we're talking about. In this case, we don't include the 3, but that's the idea behind it. Okay, so for the last one, let's try, what have we used? What have we not used? We're missing 1. Let's try x is less than or equal to -2. So actually, you know what? Let's make it a -4. There we go. X is less than or equal to -4. So what do you think? So we're starting at -4. So 1, 2, 3, 4. -4 is right here. Now, is it open circle or a closed circle? So you remember, it has this equal sign. We're going to include it. It's inclusive. So we're going to make a closed circle. And it's less than. X is less than or equal to -4. So we're going to the left. And we can plug in -5 right here. -5 is less than or equal to -4 because it's less than -4. And if you were to plug in anything to the right, if you accidentally went this way to the right, you could pick a 0. Is 0 less than or equal to -4? That's not right. So that's why we don't go that way. Okay. So again, it really helps that we can go back and plug in and see if we got the answer right, because, a lot of times you can't do that. You can't do that very easily on a homework or math assignment or a test or something like that. But with these, you can. With a lot of these algebraic concepts, if you have time, you can go back and if you got the answer right. It's really convenient, and I highly recommend it. I tell everybody that I work with, go back in and double check. If you've got time, go back in and double check, and you'll know if you got it. We working with. And with these ones, usually it's a 50-50. If you got it wrong, 3, then you just -4, and we need to figure out, is it an open circle, is it a closed circle, and is it less than or equal to? And then also, which way do we go with that? So when you think of less than, think of going to the left. When you think of greater than, think of it going to the right. Okay. When we're talking about single variable solutions like these. Okay. But other than that, the intuition behind these that's pretty much it. We'll go in the next video and we'll start with one step where we have to actually solve for something. We're not just given the let's say we're not just given x is less than 2. We need to do like one step. And I showed you before, like maybe something like this. We need to solve it on both sides, and then we get that, and now we can graph that. Okay, and then they'll take it even further. Sometimes they'll give you multi-step. Not sometimes, you will. It's a progression type of thing, obviously, just like everything else in algebra. But they'll give you like a 2x minus. Well, that wasn't a minus. That was less than 2x minus 2 is I don't know why I'm stuck on 2's, but we'll have a plus 2, and then we get this, and then we do one more step, dividing both sides by 2, and we get this, and we get that. Now we can graph that. Okay, but again, the intuition behind these is I wanted you to be comfortable with this video on how we actually graph inequalities. And from there, then we can just take it miles ahead, okay, until we get to systems of inequalities. I wanted to say in the beginning, this wording up here, graphing single variable inequalities, if you haven't seen, what we worked on, it can be an intimidating thing when you first see it, especially maybe on your syllabus or something like that. You're like, what is that? What is that? But when you actually work on them and see them, they're not bad at all, okay? So I hope this video was helpful. For some reason, I was stuck on 2's. I don't know why there's 2's everywhere. I apologize for that. Not a lot of variability with this, but the idea is the same, okay? So if you have any questions or comments, please leave them below, and look forward to the future videos where we go a little bit step further, and another step further, and another, until we finally get to where we want to be, to where you're trying to get to with these inequalities, okay? So until next time, this is Justin with Top Tier Math.